Hey Aztecs, I just wanted to follow up on our discussion around financial feasibility from our last class. The whole conversation, so when we start talking about money and the costs of projects, the first thing that we need to understand is the time value of money. A dollar today is worth more than a dollar tomorrow, and that is due to things like risk, inflation, and other factors, but it's something that's really important. So as we think about evaluating a project financially, the first thing is that a project is an investment, and so we're going to treat it like an investment. And we need to evaluate all parts of the project and all the finances of a project in terms of net present value. So I want to evaluate all future cash flows, cash outflows, and cash inflows. Cash outflows being all of the cost that you identified as part of your as part of the existing system and the future system and the gap between it. There's a whole bunch of costs associated there, and there's a whole bunch of benefits. That's the cash inflow part. And so hopefully you've done a good job identifying costs and benefits, and those are the things, those economic factors. We're going to translate that into a present value for today. So in order to do that, we're going to use a present value formula, and we're going to take whatever the future values are of those cash inflows and cash outflows and move them into today's terms by using a discount rate. So a discount rate is created usually by your finance team, and the way that they do that is they look at a weighted average for the cost of capital. You might say, what's the cost of capital? Well, enterprises typically don't use their own money to make their investments. They use other people's money. They use money that they get from banks, which we can call bondholders, and those bondholders expect a certain rate of return on their investment. So there's a cost associated with using money from banks, called it a cost of debt. And then the other way that enterprises raise capital is by selling shares, so equity, and there's a cost of equity. So the cost of debt and the cost of equity are what a finance team will use to create the weighted average cost of capital. So there's an internal cost of capital. Anytime I want to make an investment, I have to first cover the cost of capital. And when the finance team is working with that, they look at the cost of capital and then they consider risk and other factors, and they pad that number to create what is called a discount rate. And so I, in our equation for present value, is the discount rate. N is the number of periods that we expect the investment to last. And then future value is the value at any given period. So if we have an example, a project that promises $1,000 profit at the end of the first year with a discount rate of 10%, we'd plug that into our equation, and we have $1,000 for the future value, and then 1 plus 10%, and that yields $909. So $1,000 a year from now in present terms is $909. Okay, so anything that I do in order to, if I do a project, I always have to consider the present. I need to put it into terms of present value of money. So when we start to talk about the next thing, which is the discounted cash flow analysis, this is where we take all of the expected monetary gains and losses from the project. So your cash outflows, all the costs, all the cash inflows, all the benefits, and then we discount it based upon that discount rate to make it look like what the value would be if everything happened today. The result of all the cash inflows and all the cash outflows, when we mash them together, and we are able to add them up, we get a net present value for the project overall. So how much value is created or lost based upon doing this project? That's the result of a discounted cash flow analysis. It's the net present value of the project. So these two terms are used. Sometimes people use them interchangeably, but discounted cash flow is the analysis part, and then net present value is the result of that. All right. Generally, the higher the net present value, on a project, the more appetizing it is. And we would look at all projects, and the things with the highest net present value tend to have the priority. If it doesn't have a net present value above zero, we can probably immediately say no to it. So let's jump into an example. If you've done your job on your field project and you've collected a whole bunch of costs and benefits, and you assumed what that looks like over time from an investment perspective, you're able to fill out a table that looks something like this. You say, year zero, I understand what my total costs are. I might not have any benefits in year zero. Year one, I know I still have cost. In this case, it's $17,500. And year one, I start to accrue benefits, which is $12,000. The net result of year one is I have $5,500 still of cost, so I'm still in the hole. And then year two comes along, $12,000 in cost, $88,000 in benefits. And year two, I'm actually on the positive side now. And it kind of continues like that. So all these numbers are not in terms of present value, though. So the first thing I need to do is I need to take each of these series of numbers and translate them into present value. To do that, we have to do the math. We're going to look at each period's cash flow, and we're going to apply the discount rate that were provided by finance. In this example, it's 8%. So I'm going to plug in for each year, I'm going to do the math, and I'm going to get a result of, in year one, $17,500 divided by 1 plus 8%, which is the discount rate provided by finance. Exponent is 1 for the first period. That equals $16,200. So today, if $17,000 a year from now is worth $16,200 today. And I go down the row and I do that for each of the years. Notice that in year zero, it's basically the same thing. We don't apply the discount rate, or if we use the formula, the result of the value is that it's the same value. So I wanted to call out year zero. It's a little different. So if I add all these things up, the total of all of that is $255,000, right? But what we're really interested in is net present value. So this is just the discounted costs. I'm going to do that for my benefits row as well. And then I can either sum them all together to create a final number, or I can do the same activity for each of my net yearly cash flows. And when I do that, I end up with the net present value of the project or the investment. In this case, it's a positive number. It's $27,000. And because it's a positive number, we should definitely consider doing the project, and we should compare the net present value on this project to other projects to prioritize it accordingly in our strategic IT or our IT strategic roadmap. All right, so that's the first one, discounted cash flow analysis and net present value. Our next model that we will talk about is return on investment. And this is simply the total income of the project divided by the total investment or the outlay. So net benefits divided by the total cost of the project gives us a specific ratio. If it's just year zero and it doesn't go longer than a year, then we don't need to account for a discount rate. But in most cases, most projects are going to be longer than a year, and so we want to apply the discount rate. So then it would be total discounted benefits minus total discounted costs, and that gives us our net present value number. And then we divide that by the total discounted costs. Okay? So in our example, the higher the ROI or the higher the ROI ratio of benefits to cost, the better. So we want a bigger ratio. A lot of organizations will actually have a threshold for this number. Just like NPV has to be greater than zero to proceed, a lot of times ROI has to be above a certain threshold in order to proceed. So if we take our project again, we can do a calculation to get kind of the discount factor, same thing. But since we've already done that work, in this case, what we want to start to look at is we want to take the net present value, which is the benefits minus the costs. We know that that number is the 27,000 number. And then we want to divide that by the total cost. And that's going to give us our ROI. So $27,000 divided by $255,000 is 11%. That's our ROI for project one. Pretty good. So that's how you calculate ROI. Moving into the last analysis or quantitative model that we're going to use, it's called the break-even analysis. And the goal with the break-even analysis is to determine how long is it going to take for me to get paid back. It's the period of time it's going to take before our accrued benefits surpass our accrued costs, or how much time does the investment take to recover the initial cost. To do this, we're going to track our cumulative net cash flow across each year, and it's not the discounted yearly cash flows. It's cumulative now, and when we look at that, then we can immediately see what year, when the transition from negative to positive is on any given cash flow or any given project. And again, this is also used as a threshold. A lot of companies will say we have to have a payback period less than 18 months, for example. So the combination of net present value greater than zero, ROI higher than a specific target, and payback period less than a specific target, these three things then all play into an enterprise's financial feasibility study and saying whether this project is financially feasible or not. All right, let's take this last example, kind of step through again. Same numbers as earlier examples. We have this net discounted cash flow. So this is the net of both the cash outflows and the cash inflows. And then we're going to create a cumulative number. So you'll notice that year one for the cumulative number is 228. So that is simply my first year's value of cash flow, 223,000, plus year one, that's 5,000, that becomes 228. Then year two is 228 plus 65. Because it's a negative 228, it's now negative 162,000. And I just keep adding. Negative 162 plus 95 is 67. Negative 67 plus 94 becomes 27. And that's easy to see now. Somewhere between year 3 and year 4 is my break-even point. So my payback period is going to be a little longer than 3 years. I know that. So the way that we can calculate a break-even or do break-even analysis is through another model. So we have the cash flow for whatever year we're looking at. So for us, we're looking at that kind of third year, minus the first positive accumulation of cash year, X, and then divided by the cash flow of year X. So again, 3. So if I were to kind of play this forward on this example, I'm looking now at here is the first positive year, right? Year 4 is the first positive year. So I know it's between these 2 years. So year 4 is 94,000. So I want to plug 94,000 into this value. Into that value. 94,000 becomes the cash flow of year X. And then the second thing is the net cash flow of year X. That's the 27,500, right? Our net present cash flow. And that yields me 0.71. So I have now a break-even ratio. So I know that somewhere between 3 and 4 is where my payback period is. In fact, I know it's actually year 3 now because of this calculation, and it's 3.71 years that it took me to get my payback period. Okay? So that's how you do a break-even ratio. You can also use Excel to do payback periods, and I'm going to share a video with you that will walk you through that. So it's another way to easily assess a payback period. But the other option is to graph it. So I can take my total, the discounted costs and the discounted benefits and put them on a graph. So if I've done that, here's my discounted costs, Here's my discounted benefits. When I get them on the same graph, you can tell it's somewhere between year 3 and year 4, and in fact, 3.71 years. So a few different ways to look at this. Hopefully this makes sense. These are the 3 different capital budgeting techniques I'd like you to use on your field project. Discounted cash flow analysis, which yields a net present value of the investment, your project. Return on investment ratio, using net present value. So you want to make sure you use the present value and put that into present value terms. And then finally, break-even analysis to determine the payback period. The payback period of your project will be important. So these are all parts of the financial feasibility study that you will do for your project. All right. Hope this makes sense. Onward and upward, Aztecs. Enjoy the rest of your week. Cheers.